Go ahead, Jake. I hear you over there mumbling about something.
I said on like A, I know like the bottom is like positive 5. I know, I think it's like the X is positive 5.
Okay.
But I forget what to do with the top.
Okay. So let's look at our problem here. And there are two things that we need to be paying attention to when we're dealing with domain. As Jake indicated, the denominator can never be 0. You know that already. That's nothing new. You know that. The denominator can't be 0, which automatically means that x cannot be 5. Now notice that says x cannot be 5. All right? Now, what is the other rule? The denominator is one rule. What's the other rule?
If there's a radical, it has to be greater than or equal to 0.
Whatever is under the radical has to be, oh, Kendall, did you sign up and put your money in?
Yeah.
Okay, good, thank you. Okay, the other rule says that if you're under a radical, you must be greater than or equal to 0. So x has to be greater than or equal to 3. Okay, those are the two rules. So when I say domain to you, you're immediately thinking, okay, do I have a denominator? If I do, it can't be 0. Do I have a radical? If I do, whatever's under it has to be greater than or equal to 0. So now I'm going to look at what my answer is going to be. So I like a number line. You do not have to write a number line. Your answer is going to be an interval notation. On the number line, I see I have to be bigger than or equal to 3. So that would look like this, right? But I can't be 5. So I have to skip over 5. So what can I be? Well, I can be everything from 3 to 5, right? Or I can be everything from 5 on. Got it? All right, let's look at B.
So my dad called me and apparently I have an early dismissal that I didn't know about.
What time?
Right now.
Oh,
I was
well,
supposed to leave like 10 minutes ago.
okay. You need to go down to the attendance office and check out.
Oh.
But okay. We will miss you. We have a quiz on Monday.
We'll miss you so
Yep.
much.
All right. Now, look at B. What do you notice about B? Well, do I have a denominator? No. Do I have a radical? No. So therefore I have no issues, and my domain is what? The whole number line. The whole thing. So that one, my domain is this, because there is nothing to restrict it. What restricts your domain? Denominators and radicals. If you don't have those, you're unrestricted. Perfect. All right, what about H? Or problem C, function H. I have a denominator, and I know if I have a denominator, it cannot be 0. So in this case, x cannot be 1/5. Do I have anything else to worry about in this problem? No. So my domain is everything except 1/5. So on the number line, and again, you don't have to draw one, but it would be this. This is what you got, the whole number line except 1/5. So how would I write that as an interval? Negative infinity, go ahead.
So 1/5 with a parentheses in U, parentheses 1/5 term infinity.
Perfect, that's it. D. What's this domain?
3x plus 2 is greater than or equal to 0.
Yep, it's a radical. Whatever's under a radical has to be greater than or equal to 0. So that means x has to be greater than or equal to negative 2/3. Right? So again, you do not need to draw a picture, you have to write an interval. So what's that interval gonna be?
Negative 2/3 to infinity.
Negative 2/3 to infinity. What kind of symbols? Bracket at negative 2/3 and parentheses as always at infinity. Right? Yeah. All right, one more. Tell me about this one.
2x squared plus 1 equals 0.
Well, I want you to think about this for a minute. 2x squared plus 1 cannot be 0, right? Now you can go ahead and solve that. If you solve it, do you see what's going to happen? Aren't you going to get imaginaries? I think it would be great if you would look at the problem though and say to yourself, can you square something, add it to 1, and get 0? Is that possible? Because if you square something, isn't it positive? So a positive plus a 1 will never be 0, will it? So in other words, the only things that would make this 0 would be imaginary, and imaginaries have no place in function land. Okay, these are graphable things. So what's my domain? All reals. Bingo. There is no number that will mess this up. Every number is okay. Nothing will mess it up. All right, let's look at number 2. I graphed this little picture for you, and I've asked you to find the range of the picture. What do I mean by the range? The y's. Range is y's, right? So tell me about the y's in this picture. Is it everything? Do I have all the y's in this picture? No. What y's do I have in the picture? 3 and down, which I would write like this, wouldn't I? Isn't that 3 and down? Positive infinity would mean up. I don't want up. I want 3 and down. That's the range of that guy. Now, this next question, find the special symmetries. Now, the special symmetries are x-axis, y-axis, identity, and origin, right? In any order, it doesn't matter. I'm just kind of writing down as I'm thinking about. Okay? We want the special symmetries for this equation. So let's run through our tests real quick. What is it for the identity line? How do you test for symmetry with the identity line? I love it. Sharon's going to her notes. She says, Miss Ford, we just did this. I don't have it memorized. I'm going to my notes. That's where we should be. What is it, Tina? Switch the x and the y. So this would become x squared equals 7y plus 1. Boys and girls, you don't make it hard. You literally take the y's and make them x's, and take the x's and make them y's. And then you stand back and look at it. Is that equation the same as this equation? No. So that's a no. All right, what is the test of symmetry for the x-axis? Make your y negative. So negative y, put it in parentheses. Put it in parentheses. Is that going to simplify to be the same equation that I started with? What's negative y times negative y, Peter? Isn't that positive y squared? Yes. So that's a yes. That one's a yes. All right, what's our test for the y-axis? change the sign on X. Do whatever simplifying you need to do. Some of you can just tell at this point, no, those aren't gonna match. Those aren't the same equation, right? Got a negative. And what's the test for the origin? Make them both negative. So remember, if you wanna put these negative things in parentheses to make sure you're doing all the right operations with them. So isn't this one gonna be that?
Yeah.
Which does not match the original. Remember, we're comparing it to the original. So this one has only one special symmetry, and it's the x-axis. Keep in mind, you can have none of them. So whatever equation I end up giving you, it could be none. Or it can be more than one. So you just have to do your tests and then you check. Vocabulary. What do we call a function that has symmetry about the y-axis? This one does not. But if it does have symmetry about the y-axis, it's called even, bless you. And if it has symmetry about the origin, it is called odd. Just a little vocabulary. Finally, solve algebraically. Algebraically means we're not graphing it on our calculator. We are solving it the good old-fashioned way. So what do you suggest we do here? Oops, I can't read the end. Can anybody read the end there? X plus 1.
I think it's
I'm gonna say x plus 5.
That's the minus one.
X minus 1. Thank you. X plus 5. What do we do? Come on. Distribute everything, everywhere, everything. So 3x minus x squared minus 7x minus 2. First, outside, inside, last. Now what do you think we ought to do? This is a pretty big equation. What do you think we ought to do now? I would combine my terms, and because it is such a disaster, I would probably do each side individually. So I'm just gonna focus right here, and I have negative x squared minus 4x minus 2. Now those of you guys, you have young brains, you can function better than me. You can start moving things around if you want, but I'm just adding these together, hopefully correctly, and then adding these together. Did I do okay?
yeah.
All right, now what?
Now put everything on one side.
Exactly. Doesn't matter which side you go to, but you want to get this equation set equal to 0. Always your quadratic equations, x squared equations, need to be set equal to 0. So I'm going to go ahead and add x squared, add 4x, and add 2. You can go the other way. It does not matter. So 4x squared, 8x minus 3. How's that? So that would, if you moved it the other way, you'll have negative 4x squared, negative 8x, and positive 3. Now what? Solve it somehow.
Quadratic.
So the quadratic formula would be my preference, but you could complete the square and try to factor it. I don't think it factors. So I'll just use the quadratic formula. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Did you get 112? Now, two things at this point. Do these cancel? No. The only way you can cancel in an expression like this is if you can cancel those three spots. And since there's not even a number there, there is no canceling at this point. But what can I do? What about 112? It breaks down into something, I don't know, I may not be able to simplify it, but 112 is 2 times 56. 56 is 2 times 28. 2 times 14, 2 times 7. So if I broke it down correctly, I have a 2, a 2, a 2, a 2, and a 7. So out will come a 2. Out will come another 2. And in will be a 7. Now can I cancel?
Yes.
I can take a 4 out of everything, so negative 2 plus or minus root 7 over 2. And there's our final answer. All right? Yes, Mrs. Ford, that's awesome. Okay, so that's gonna be our quiz on Monday. All right, are we ready to move on? All right, let's get our notes out. According to my record keeping, we are on page 12, getting ready to talk about number 7. A discontinuity is anything that breaks your graph. So a discontinuity is anything that's going to break your graph into pieces. So let's take a look at this function. And let's forget what we're trying to do here. Let's just pretend we found this function somewhere. What would you do with this if you just found it? Is there anything you could do with it?
Oh, we're
Well, multiplying by x wouldn't get rid of the bottom. Multiplying by x would make it x squared on the bottom. So that would make it worse actually than it is. I think I would do the opposite of that actually. Come on. What can I do to the top? Take an x out. And what's gonna happen when I take out an x? It gets rid of the x. This is what we call a removable discontinuity. Now let's talk about that for a second. In the original problem, think about the quiz you're going to take on Monday. What can you tell me about the domain of the original problem? X cannot be 0. Any cannot be is going to be a discontinuity. Think about that on the number line. Forget about the actual picture, but on the number line, doesn't that break up your shading? And if it breaks up the shading on the number line, it's a discontinuity. So in the beginning, x couldn't be 0. That's breaking your picture. But what were we able to do with that denominator? We were able to remove it from the problem. So it's a discontinuity, and look at the original problem, can't be 0, okay, but we were able to cancel it out. So it's called a removable discontinuity, otherwise known as a hole. And it's at the point where x is 0 and y is 1. So whatever this thing looks like, this weird picture when I graph it, whatever it looks like, there's going to be a hole in it at the point 0, 1. Now, removable discontinuity happens when you can cancel. If you can't cancel, you do not have a removable discontinuity. Do you understand why the hole, the removable discontinuity, the hole, do you understand why it's at the point 0, 1? Well, x is 0 is what got canceled out, right? And then if I plug 0 back into my problem, it gives me a 1. That's how I got the 1. So there's a hole at 0, 1. Now look at B. Are we going to do any canceling here? No canceling. Please don't cancel unless you can factor. Can't factor anything, can't cancel anything. So where's the discontinuity? What can x not be? 2. This is a non-removable discontinuity. I can't cancel it out. And it's x equals 2. That's where the discontinuousness is, at 2. It will be graphed as a vertical asymptote. So if I can cancel it out, it's a hole. If I can't cancel it out, I literally break my picture into 2 pieces at x equals 2. So, we're responsible for removable and non-removable discontinuities. What's the difference? They both come from zeros in the denominator. If you can cancel it out, it's going to be a hole. If you can't cancel it out, it's going to be a vertical asymptote. Now, we're going to do a little work with even, odd, or neither, and then we're going to do some more work with asymptotes. But this is more like vocabulary here. Removable means you can cancel it, and it graphs as a whole. Non-removable means you can't cancel it, and it graphs as a vertical asymptote. All right. We should be okay with this section. This will be good quiz review for us. It says even, odd, or neither. By the way, if it helps you, change these f of x's into y's. That might help you. All right. So tell me, you sleepy people, what are we going to do math-wise if we're determining if these are even or odd?
Doesn't have to do with like the root. Is that what it's called? X like the 4 up there.
What?
Isn't like the X.
Well, okay, if we were talking about the degree of the function being even or odd, yeah. But we're talking about the function itself being classified as even or odd. We just reviewed that. What does it mean to be an even function? It means you have symmetry about the y-axis. So you're going to do your y-axis test. What does it mean to be an odd function?
Origin.
You have symmetry about the origin, so you're going to do that test. So this is exactly like the quiz, except on the quiz you're doing all 4, And here, because it specifies even or odd, you only need to do these two. So what's our test for y-axis?
Change x to negative.
So y equals negative x to the fourth. Remember to put it in parentheses. Does that simplify to this? It does, doesn't it? So this one is definitely even. Now, what's the test for the origin? Change both of them. Is that going to simplify? No. So this one is even only. Okay, are you guys connecting this to the quiz we're taking next time?
Yeah.
Only on the quiz, you'll do all 4 tests, because this one says even and odd, we only have to do the 2, the one for even and the one for odd. All right, here we go. Same 2 tests, so y-axis means I change the sign on x. So tell me what you think about this one. For y-axis, I change the sign on x. For origin, I change the sign on both. What do you think about that? Yeah, so, yeah, one of them's for NHS, one of them's for math. And then, how to, this is their information to remind them to assign, yeah. Here's their guess. So they look at the card, you can't touch it, you don't take anything out of it. They write their name and there's just how many students are in it. Okay? They can rip, it says cut here, but they can rip their page if they want. Thank you very much. I'll see you afterwards. Okay. What did you come up with here while I was messing around with my Smarties?
I think it's just a y-axis.
I think it's even, definitely. I don't think it's that one, no. All right, couple more. Y-axis, try not to be bored. Change the sign on x. All of the x's. Don't forget to change the sign on all the x's. And origin is both. Okay, we gotta simplify those.
I think it's the,
I don't think this one's gonna come out to be the same, is it? Isn't this one gonna be negative 2x cubed plus 3x?
yeah,
So it's not y-axis.
I think it is.
You think it is this one? I think you might be right. Because if I divide through by negative, don't I get, what's my original? Don't I get my original back again? So that one is odd. One more. Change even, change the sign on x. I would say no. Would you say no?
Yes.
Odd, yeah, yes, I would say no. Origin is change the sign on both. I think that's a yes. So the top 2 were even, and the bottom 2 were odd. Everybody in agreement with that? So, even means y-axis, so you only check the y-axis if you want to be even, and you only check the origin if you want to be odd.
Let's do that last one.
Oh, sorry, forgot about that guy. Even would be y-axis, so I'm changing the sign on x. All the x's. And odd would be origin. Be careful. Like I'm changing the sign on my x's. Isn't this still gonna be this is gonna be positive x squared, right? So this is still gonna be negative x squared with the negative in front of it, only now it's minus 0.03x. I don't think that's the same. This one, I don't think this one is either, because when I divide by the negative, it's not gonna come out like that, is it? So this one would be a neither. It's not even or odd. Alright, we don't have much time. Hang on, stay with me. Everybody okay with that? Alright, so now we're gonna look at finding all of the asymptotes. We just talked about vertical asymptotes. Where do vertical asymptotes come from? When the denominator equals 0. So when I look at problem number 1, we have vertical asymptotes and we have horizontal asymptotes. When I look at problem number 1, my vertical asymptote is going to be at -1. Why is my vertical asymptote at -1? Because if I put in -1, I get 0, and 0 is not allowed, right? Cannot be -1, cannot be, so vertical asymptotes. Okay? Now, we haven't had any discussion, I don't think, about horizontal asymptotes. Does anybody remember this from last year? I'm pretty sure, well, I know if you were in honors last year, I know you did it. I think they did it in academic too. Horizontal asymptotes, do you remember how to find them? No? No recollection?
We got it, but at least I remember.
You did it, we just don't remember how. Well, here's what I want you to do. I want you to find the x's in the problem, and I want you to box them in. Just draw a box around the x's. I want you to forget everything else in the problem and tell me what x over x equals. What's x over x? 1. Your horizontal asymptote is y equals 1. Now, does it sound familiar? Look familiar? That's how we do it. Now, there's some math going on there. It's called limits. There's some limiting going on there. But in terms of just finding the asymptote so that we can eventually graph this picture, that's how you do it. You just compare those. So let's look at the next one. 2x minus 1, x plus 3. All right, tell me about a vertical asymptote. X equals -3. Make a note of this if you can't remember this. Vertical asymptotes come from the denominator. What can x not be? Clearly, x cannot be -3. So there is a break in your graph at -3. What about a horizontal in this case?
2.
It's going to be, look, y equals 2. That's your horizontal asymptote. Uh-oh, I'm trying to trick you, but I haven't tricked Nyla. She's back there shaking her head. If you're gonna have a vertical asymptote, what do you have to have? A denominator. That's where they come from. If you don't have a denominator, then you are not gonna have a vertical asymptote. So there is no vertical asymptote. Where do your horizontal asymptotes come from? Don't you have to have a fraction here to build the box? If you don't have a fraction, then guess what? None of those either. That was easy. Now, the next one is a little bit harder. So let's take a moment and look at it. You're all watching the clock. Can't wait to get to your class meeting. Woo-woo. vertical, horizontal asymptote. Tell me your thoughts on this. This problem's a little bit trickier. Do you have a thought? Nyla?
I don't think there is a vertical.
There isn't. And some of you are saying, but wait, Mrs. Ford, there's a denominator. Yes, there is. But if you're gonna be an asymptote, your denominator has to equal 0. Can x squared plus 1 ever be 0? No. So you can have a denominator, but if it can't be 0, you're not gonna have an asymptote. How about horizontal?
Or it's, yeah.
There is it's where? It's at 0. Oh my gosh, that's amazing. Here's the deal. When I find my horizontal asymptote, aren't I supposed to box in the x's? Now the problem is, I don't have one on the top. So to build my box, I'm gonna go ahead and put it in. 0 x squared over 1 x squared. So where's my asymptote? 0 over 1, which is 0. So if you have a fraction, if your problem is a fraction, box them in. You're going to have to box them in to find your horizontal asymptote. If you're missing something, put a 0 in there and build the box with the 0. 0 over 1 is 0. So that one does have an asymptote. All right, how about E? Vertical? None. Already talked about it. Can that ever be 0? How about horizontal? Yes. Yes, right there. X squared over x squared. 1. Yes. Jake?
If the denominator was x squared minus 1, is that possible to find a 0?
Yeah, you'd have 2 then.
I would.
Because if it's x squared minus 1, isn't that x plus 1, x minus 1?
Yeah.
So x couldn't be negative 1 or positive 1. So that brings us to an interesting point. A curve, we don't have one yet, but a curve can have more than one vertical asymptote.
Okay.
It can only have one horizontal asymptote. All right, we got 2 more and then I'll stop, okay, I promise. Because we're gonna be out of time anyway. So let's do these last 2. You're doing great, hang in there. Okay, Mrs. Ford is getting tricky here. Oh, Katie's not tricked. What, Katie?
You factor the denominator and then cancel out the
Bingo, we factor the numerator.
Or did I say much?
Yeah, it's okay, doesn't matter, we know what you meant. So we're factoring these out. And Katie says, this is going to cancel. So the problem is actually just x minus 3,
Yeah.
right? Now, the fact that we canceled means we will have a whole, but we don't have an asymptote. In fact, we don't have any asymptotes, do we? Because there's no fraction left. So this one has no asymptotes, no vertical, no horizontal, but it does have a hole. That wasn't the question, but it does have a hole, and the hole would be at -3, -6. How? This would be the hole. Wasn't part of the question, I'm just sharing it with you. How did I get -3 for my x? Isn't that what I canceled out? How did I get -6 for my y? I plugged it in. -3 minus 3. All right, what do you think about this one? Take a clue from what Katie said last time. What are you gonna do? You factor it all. Factor it all. So the top factors how? X minus 4, x plus 4. Guys, you gotta know the difference of squares. Come on, they pop up all the time. How about the denominator?
X minus 4, x minus 1.
Beautiful, thank you. What happens? We can cancel. So now my problem is x plus 4 over x minus 1. This time, do I have a vertical asymptote?
One.
X equals 1, let's get to have the writing equations, X equals 1. Do I have a horizontal asymptote?
One.
Y equals 1. That horizontal, you can either tell from the original problem, or you can tell from
Immediately, right back.
you leave everything here, yes indeed.